Hello everyone, I'm Golden Ashwini. I'm here to present a building data path in computer architecture and organization. So on completion of this video, students can be able to explain what is data path. Here, first of all, we need to know what is meant by data path, right? So the components of the processor that perform arithmetic operation and hold the data. Then control means components of the processor that commands and data path memory, input output according to the instructions of the memory. Building a data path. Okay, in this elements that process data and addresses in the CPU, memories, registers and ALU. Then MIPS and data path can be built incrementally by considering only subset of instructions. In this figure we can easily say that it has a three main elements. What are that? First one is a instruction memory, then second program counter, then adder. Okay, so the memory unit to store instructions of a program and supply instructions given an address. Okay, so needs to provide only read access. That means once the program is loaded, no control signal is needed. Then a program counter or instruction address register is a register that hold the address of the current instruction. So a new value is written to it every clock cycle. So no control signal is required to enable write. Okay, then adder to increment the PC to the address of the next instruction. And ALU means actually it is permanently wired to do only addition. No extra control signals are required. Then the next one is data path portion for instruction fetch types of elements in the data path. So to state this element, memory element, that is it contains a state. For example, program counter, instruction memory, combinational elements. Then elements that operates on values, that's all. For example, the ALU adder. Okay, then the elements required by the different classes of instructions. What are the instructions? Actually, arithmetic and logical instruction, data transfer instruction, branch instruction in R format, ALU instructions. Okay, then it also perform arithmetic and logical operations, read to register operand and write register result. Then a collection of the registers. Any registers can be read or written by specifying the number of registers. Then it also contains the register state of the computer. Then we have to know the read from the register as well as write to the register file. Read from the register file actually inputs to the register file specifying the numbers, bit-wide inputs for the 32 registers. Then output from the register file with the read values, then 32-bit wide. For all instruction, no control required. Write to register file, one input to the register file specifying the number 5-bit wide input for the 32 registers. Then one input to the register file with the value to be written 32-bit wide. Only for some instruction register write control signal. Then ALU, we know actually it takes two 32-bit input and produces a 32-bit output, and also set one 1-bit signal if the result is 0. Then the operation done by ALU is controlled by a 4-bit control signal input. This is a set according to the instructions. Okay, thank you. Thanks for listening.